This is the first video in the installment of complex fractions. This particular video is going to deal with monomials in my denominators of a complex fraction. So let's first discuss what a complex fraction is. So we have a complex fraction, and this is what we're doing, but what is it? So a fraction is just a over b, right? It's some number divided by some number. When we're making it complex, we're taking a fraction and we're dividing it by another fraction. So c over d, okay? And they can look a lot different than this, right? A could be a number, it could be a number with a variable. B could be a binomial or a trinomial, and same thing with c or d. It could be any one of those. So what I'm going to show you is the shortcut and how to do complex fractions, kind of the easy way, instead of doing it the proper kind of mathematical way. The reason for that is really time. These do take a long time if we get to some of the hard problems, and the faster you can do them, as long as they're still right, it'll still be okay. So let's look at this first problem here. This is a complex fraction, right? It's got 5 over 3, and then we're dividing that by 25 over 16. It looks to be a lot of division bars, okay? But the 5/3 is one fraction, the 25/16 is the other fraction, and this bar in the middle is just our dividing bar between the two individual fractions. So here's how I do this with the shortcut. If I look at my denominator in my numerator, right, because 5/3 is my numerator, and then I look at my denominator in the denominator, right, 25/16 is my denominator. What I want to do is I want to make them the same, okay? Again, least common denominator, okay? Find out what number I can turn them into such that, right, they'll both go into it. So 3 and 16, if I look and if I remember from multiplication and kind of the last previous section, I know that the number can be 48. So how did I get 48? Well, 16 times 3 was 48. Therefore, 25 times 3 is 75. Then 3 times what was 48? Well, it's times 16. So I got to multiply the 5 times 16 as well to get 80. Okay? Now, what do I do? Well, here's where the shortcut comes in. Remember, we're still dividing all of that stuff, right? Here's where the shortcut comes in. Once my denominators in both of my fractions are the exact same, they disappear. What do I have left? I have 80 over 75, right? 80 is on top, 75 is on the bottom, just like it is here. Now I need to reduce, right? I still need to reduce. It's still a fraction. I can divide them by 5. So I get 16 over 15, and that's my final answer. This next particular problem, again, it looks the same as what I just did. What I need to do is make sure I have the same denominators. So 16 and 25. These are my denominators. I need to find out a number that they can both go into. That number is 400. Now, if we're having trouble finding out the value of, the number that can go into it, 16 times what is 400 and 25 times what is 400, then what you can do is, if you get numbers that are quite large, is you can actually just multiply the numbers together, and that would give you the number that can go into it, okay? Well, which is 400. So that gives you the 400, okay? If it was 8 and 25, then it would be 200, okay? Because then 8 times 25 is 200. So that could be my new denominator. So 25 times what is 400? Well, it's 16. So multiply by 16, that's 64. 16 times 25 is 400. So 3 times 25 is 75. Now here's where the shortcut comes in. If you remember, since my denominators are the same, I can get rid of them. What do I have left on top? I have 75. What do I have left on the bottom? 64. I cannot reduce them by anything, therefore this is my answer. All right, go ahead and try this particular problem. Again, pause the video, see if you can do it, and then follow up after that. Hit play. So I need a common denominator. Common denominator is 20. Okay, that's what they can both go into. So I multiply by 5, so I multiply by 5, multiply by 4, multiply by 4. Now my denominators are the same, that 20 and that 20. Therefore, I get 16 over 5. Cannot reduce. That's your answer. Now let's go to this example here. Now I have variables. In the last couple we did not have any variables, but it doesn't matter. So I need to find a common denominator between the u and the 5. Well, what's my number with the u? My coefficient is a 1. So what number can 1 and 5 go into? Well, they can both go into 5. And then I have a variable u in the denominator. So that means my common denominator also has to have a u in it. So how did I get from 5 to 5u? I multiplied by u. That gives me u squared up top. How did I get from u to 5u? I multiplied by 5. So I got to multiply by 5 up top. That is 125. Because my denominators are the same, I get my numerators of both fractions. U squared over 125. Cannot reduce. That's your answer. Again, we got variables in this one. That doesn't matter. So my denominator is 5 and x squared. What can they both go into? Well, because one has a 5 and one doesn't, that's 5. And one has an x squared and the other one doesn't. That's why it's 5x squared. 5 times what is 5x squared? Times by x squared. So times this by x squared. That gives me 2x to the third power. X squared times what is 5x squared? That's times 5. So multiply the 4 by 5 to get 20. Now because my denominators are the same, I get 20 over 2x to the third. But they're both monomials, therefore I can reduce them, divide by 2. So that divide by 2 is 10, that divide by 2 is 1. So final answer is 10 over x to the third. If you want to, you can put the 1 there. That's fine also. Go ahead and try this particular problem. Again, pause the video and then hit play once you get done. So common denominator we know is going to be 3x. So 3 times what is 3x? That's times x. That gives me x to the third. X times what is 3x? Times 3 times 3 gives me 3. So denominators are the same. X to the third over 3. Cannot reduce because I don't have any numbers up top other than 1. Cannot reduce with the x's because I don't have any in the denominator. That concludes this video with monomials in the denominators of my numerator and then my denominator there. If you need help with binomials or other terms, more terms, then please tune into the next videos.